All right. So this one is helping us already to recognize that 2 to the x is the parent graph. So I'm going to just go over here and put a little square around the x and a square around the 2, almost too big of a square. So I realize that those numbers are not going to affect my transformations. However, can you see in this one, we do have a horizontal reflection and a horizontal translation. So before we do anything, we have to factor that out. So I'm going to rewrite it. I'm going to put the 2 in a different color. We're going to factor out that negative. And then instead of x plus 2, it becomes x minus 2. So the green numbers are not going to affect our transformations. We're going to think of our 2 to the x graph. We'll quickly draw a sketch of it here. We know it has an asymptote at y equals 0. It swoops up. Don't like that color. It swoops up like this and has the point 0, 1 and 1, 2. So there's our original graph. Now, when we want to graph this one, we're going to take those points. 0, 1, 1, 2, and our asymptote y equals 0. When we move from left to right, first thing we run into is the 3. That is going to multiply y by 3. Then we run into the negative, which will mean x gets multiplied by a negative 1. So you can do your stretches, compressions, and reflections for both x and y at the same time and see what you get. You're going to get 0, 3 and negative 1, 6. Then we haven't done the minus 2. That is going to move it 2 to the right. 2, 3 and 1, 6. What's going to happen to our asymptote? It's going to stay the same because it never moved up or down. On your exam, if an asymptote is on an axis and you say, oh, you can't really see it because it's on that axis, I'm not going to bother labeling it, they will take off a half a mark. You need to show a dotted line on there. It's good to always use a red pen, that way it shows up over top of the black axes that they'll probably give you, and label it with its equation y equals 0. So what are the points that we have? We have the point 2, 3. And again, we label that to give our graph a scale, and 1, 6. And now because of those 2 points, it has to swoop down. Again, if we think about our original graph, when we had that reflection in the y-axis, that would flip it over like this, and that's the general shape that we have in the end after it's been stretched and moved to the right. So now if we look at our equation, is our function increasing or decreasing? It's decreasing. Do we know any intercepts? Well, there's going to be no x-intercepts, but there might be a y-intercept. There might be a y-intercept. Well, we know for sure it's going to cross at some point. How would you figure out that point? Plug in 0 for y. So let's go down here for part 2. If we plug in 0 for y equals 3 times 2 to the negative x minus 2. And you have to solve. Oh, plug in 0 for x. Thank you. Yeah, we'll plug in 0 for x. ooh, that was fancy, negative, wow, that doesn't erase, maybe it'll go away. Okay, y equals 3 times 2 negative 0 minus 2. And plug this in. So what do we have? We're going to have y equals 3 times 2 to the power 2. And you'll get y is equal to 12. So we would know that this point here is 0, 12. What is the equation of the asymptote? It stayed at y equals 0. The domain of all exponential functions will always be all real numbers. The range of this one is based on the asymptote, and it's going to be y is greater than 0, or you can write that in interval notation as well. Question number 10 is one that you can do